Hello, folks. Welcome to another edition of Tantra's Mantra, a podcast that goes behind and beyond the tech news headlines. Today, we are going to discuss an exciting subject and sometimes quietly hyped a bit. It's the world of robotics. And we have a special guest today to discuss this with. And that guest is Mr. Dev Singh. Dev is the General Manager of Robotics, Drone and Intelligent Machines at Qualcomm. Hey, Dev. Welcome to Tantra's Mantra show. How are you today?
I'm good, Prakash. Thank you for having me over here.
All right. So, Dev, thank you very much for coming over. I think you've been a Qualcommer for some time now, right? Anything you want to share with our listeners on how our journey has been in Qualcomm, what you've been doing?
Sure. Thank you for asking that. Yes, I've been at Qualcomm for quite a bit. It's been over 7 years now, and the journey has been quite interesting. And not only at Qualcomm, I would say that that's been an interesting journey throughout my career as well. Before Qualcomm, I was at TI, where I worked in wafer fabrication facilities to the front end of business and design implementation. And at Qualcomm, similarly, I have held multiple different positions. I was in the technology side where I was overseeing the multimedia technology aspect of things, the GPU, DSP, and the compute, the AP processor, program management, and then also operations and few others. So had a very good, interesting view of things across the board. So I've been blessed in that way. 4 years ago, I did this business case of robotics when Qualcomm was looking at adjacent businesses beyond mobile, and we formed this IoT business unit. Mm-hmm. And within that, I did the business case for robotics and started this product line, which has been doing really well and taking off.
Yeah, very exciting times, I would say. So you had this great product announcement, I think last week or a couple of weeks ago, which got a lot of attention and a lot of press about it. We'll talk about that in a little bit. Let me start up with the industry status as such. As we all know, robotics, drones, and others have gone through hype cycles. From your perspective and Qualcomm's perspective, where do you think industry stands right now? I mean, it's the hype cycle over now, where rubber meets the road. You're trying to get products out and such. And how do you foresee this moving forward?
Great question as well. Yes, you're right. I mean, robotics is not a new field. We've been hearing about robotics for quite some time. Even the new things like AI, when you talk about AI today, is okay. AI is applicable to everything today. But when you look at AI 10 years ago, if somebody said AI, artificial intelligence, first thing that would come to mind would be a robot. That was the perception. The Rosie of the Jetsons is the poster child for robotics and AI. And today, we are seeing all of that happen. So it's been an interesting area for a lot of time, especially around creating autonomous systems around people's lives and industries to enhance their lives and efficiencies. So that has been viewed very well. I mean, that's how it has been viewed. But through the time, it had remained in mostly a hobby market kind of approach, because people wanted to build this cool robots, but at the same time, the cost and the integration and how things were available to the robotics industry were different. Now, I think the robotics industry has gone through a lot of things. The technology has exponentially increased. Robotics is a very complex thing. There is a lot of things involved. There is compute, there is the technology aspect of things, but at the same time, there is mechatronics, there is mechanics of the robots, there is motor control. It's a system level problem. And to solve a system level problem, in past, people have done this using general purpose compute elements, general purpose things off the shelf, trying to do a Frankenstein thing of putting things together to make it happen. And that's the challenge for robotics. I mean, if somebody has to make a robot and create a use case for the robot, now they have to worry about cobbling up everything together, including the compute, the mechanicals, the sensors, and all of that. So that has been the challenge. And today, the exponential increase in technology, the cost of the compute being available in the form factors that make sense to make safer products, safer drones, safer robots is here. So it has come to a point where there's an inflection point where we are seeing a lot more things can happen with the technology available today. So that's where we are.
Perfect. So may you preempted a little bit of my next question, which is, what are the major challenges the robotics industry has today? I think you explained it very well. And now my question is, how are you guys at Qualcomm are preparing yourself to address it and solve it?
Great question. Like we talked about those challenges are critical to be solved. Those challenges are things that are on people's mind. At Qualcomm, what we have is a portfolio of technology and a breadth of technology. And what we are doing also is we are serious about robotics. We have doubled down on robotics. We have already powered millions of robots out there. We have robots in the cleaning robot segments. We have robots in the industrial segment. We have robots in the enterprise segment. We are understanding the pain points across all these products or variety of robots. And at the end of the day, if you look at the DNA of any of these robots that I talked about, it's sensing, thinking, acting, and communicating is what a robot does, be it a $200 toy robot or a $2 million factory robot. That's what they do. And at Qualcomm, we are putting solutions together that give the right building block and bring in the integration to address all these key building blocks for a robot, so people don't have to worry about cobbling things together. And we give them a platform solution that can be a right building block and a good starting point where they can start developing their functions on top of it. That's how we are understanding the market requirements, understanding the pain points, and addressing it by putting development platform like the RB5 platform in their hands to be able to take their headaches away.
Yeah, excellent. So yeah, you mentioned RB5. There's been a lot of press around it. I have a challenging question for you then. The tagline of RB5 is it's 5G and AI, the two most used buzzwords in the industry now. Can you give me 3 features of your RB5 platform without using 5G and AI?
Great. I mean, of course, there's many things that I can talk about, but you asked for key 3 features. Okay, let me boil them into 3 top features. Like I mentioned, the challenges of robots, right? So heterogeneous compute performance at ultra low power consumption is one of the key feature, which brings in all the compute you need, but at the ultra low power consumption, which is very important for battery operated robots and drones. So that's number 1. Number 2, computer vision and camera capabilities. So this platform has a dedicated computer vision engine, which is a hardware accelerator that provides real-time analytic data for imaging applications, computer vision applications like visual inertial odometry or depth from stereo, which is very important for making an autonomous robot. That's number 2. And of course, in part of that is also the camera, because this has a great gigapixel camera ISP, which can do, say, 8K video to 7 camera concurrency, again, important for robotics applications. So that computer vision and camera capabilities is number 2. And number 3, if I have to underscore all of this, is vault-like security. From crypto to DRM, the secure processing unit that is on this platform helps secure robots at all levels, be it secure manufacturing, over-the-air update. Security is very, very important for robotics, and this one has it. So there you go. You have your top 3.
All right. Pretty good. Yeah. So you mentioned about heterogeneous compute, right? So, I mean, there are companies who rely only on GPU. There are some companies who only rely on CPU, and some only on DSP and such. From your point of view, how is this heterogeneous compute important enough for robotics? Why can't I just take one kind of compute and make use of that to do multiple things rather than going to these different blocks?
Thank you for asking that question. I mean, I try to answer that to my friends as well. I try to simplify it, saying, okay, if I give you a knife and I tell you to open a bottle, would you be able to do that? So that's kind of the thing for robotics, where you have multiple challenges in robotics. We talked about multiple kind of robot. There's a drone, there is a robot that needs to do vision application, that needs to do AI, that needs to do real time voice activation kind of application, that needs to do image correction for inspection and few other things. You truly need a Swiss knife kind of analogy, if you will, for robotics application. And that a heterogeneous compute architecture is where you can use CPU for things that you need CPU for, which is real time, and you need a tremendous horsepower at the given instant of time. But then you need sustained performance at a very good power efficient level, where you have always on kind of features that you can implement on DSP. And then you have image applications or dewarping and few other things that you can implement on GPU. So you actually need this kind of a flexible platform that can help you put your applications where it is suited best to be on.
Yeah, perfect. And also, I mean, when you're creating something, a platform like this, you don't know what all other applications out there that people might use this for, right? So having that flexibility, I think, really helps out in making sure you make best out of what you got for the specific application that you might be designing the your robot for, right?
Totally.
Yeah. So now coming to this, the two main pieces that you mentioned about 5G and AI, I'll focus more on 5G a little bit. There is a lot of hyperbole, I would, if I can say that, on this Industry 4.0, 5G enabling and such, which I think a lot of it makes sense, but is long term a little bit, right? Right now, I mean, 5G is primarily focused on providing enough capacity, coverage, and everything for smartphones and such. So, what is the actual role that you see for 5G in robotics, say in next 2 to 3 years, and then how would that change 3 years and beyond that? A clue on how to start is, can you explain how 4G is used right now in robotics and how that might change with 5G and such? So, overall, specifically how 5G will change robotics. What is the feel from the field? What are the things that you're actually working on where 5G would be useful?
This is a good one as well. Yes. So, as I mentioned earlier, building block for any robot is communication. That sensing, thinking, acting, and communication. So communication is a key building block for a robot. Robot needs to interact, be able to communicate back on the data it's getting, and few other things. So now, if you have a robot at home, of course you don't need maybe cellular connectivity, maybe overkill because you have Wi-Fi and others. But now the segments in robotics is going to be consumer, enterprise, and industrial. Now, when you talk about enterprise and industrial, especially in the enterprise, you may have heard this term as robot as a service, where people are providing robots as a service, be it to big clients like Walmart, where BrainCorp is providing floor cleaning robot there, or construction sites where people are providing robots as a service for accomplishing certain projects. So it's a robot as a service is the thing. And in those kind of applications, what is the connectivity there? When you need connectivity, it is mostly going to be things like cellular connectivity, because you don't want to depend on the end client's Wi-Fi. You don't know how good that is. You have things around places there's no Wi-Fi or no connectivity where you can put private networks. So today we are seeing that cellular is used basically one of the key means for communication in these kind of settings where you want connectivity and you don't have connectivity, and also it's in the enterprise use case where it's more around remote applications kind of stuff. So that is where we are seeing it being used today, for sure.
Okay.
And how 5G is going to be different. Yeah, so 4G is again 4G or LTE or CBRS private networks is part of the connectivity portion of things. But when you talk about the future of lights out warehouses, when you
Mhm.
talk about the future of Industry 4.0, which is a totally reconfigurable factory, or mission critical stuff, latency, reliability, throughput becomes absolutely necessary. And these are mission critical things that quality of service is imperative. That is where 5G is the differentiator. When 4G is still a communication means, but then the reliability, the latency aspect of things will be solved by 5G, and that's where the use cases will also evolve. And you will see more and more robots becoming more efficient, more prominent in those kind of use cases.
Cool. Yeah, agreed. So, are you guys working on any specific applications, either on a trial basis or actual commercial application, where 5G would be used?
Absolutely. Yes, we are.
Mhm.
I mean, there's some we cannot share publicly, some we can share publicly, but yes, we have announced a lot of collaboration. I mean, if you heard of the show called Hanover Messe in
Yeah.
2018, 2019, we did a lot of proof points or demos with our partners as well. So we did have a 5G arena and a 5G pavilion where
Hmm.
we had partners like Bosch and others show their factory of the future use cases where we are working with them on proof of concept around AGVs in the factory, around multiple robot arms being able to use this kind of ultra reliable, low latency application. So, yes, we are working on a lot of these things. We are part of something, what we call it as a 5G ACIA, which is Alliance for Connected Industries and Automation. We are part of that alliance. We are having strong industry collaboration. We announced a research collaboration with Bosch in February 2019 as well. Yeah, we are doing a lot of stuff in terms of proof of concept, in front of pilots with key players and key partners.
It's early times for 5G in IoT. I understand that, but what is the time horizon you're looking at?
I think things have started. I think even in 5G, one thing is critical to understand is 5G, the 3GPP body, which works on the 5G standards. Release 15 is one which is now rolled out, and release 16 is being implemented. So, release 16 and release 17 are these ones that are coming in next few years would have most of the features that are needed for industry 4.0 kind of applications like ultra reliable low latency, the time sensitive network, and all of these are part of the release 16. And the release 17 will have even more use cases around unmanned aerial vehicles where you can have remote IDs and things around UTM, that is air traffic management kind of application. So you will see, I mean, things like I mentioned earlier, we are working with partners who are you doing proof of concepts in their factories. Of course, they're not converting the entire factory to a 5G floor, but what they're doing is a section of it where they're converted to a 5G proof of concept prototyping and pilot projects. They're trying to make sure the use cases are well understood and they can think through the applications. So that part has started. So it will be a matter of time when the digital twin and 5G adoption and the private network will start happening in the factories, and the robots also will go along with that. But I think next 2 3 years you will start seeing more and more adoption.
Okay, I am a 3GPP member, so I attend all their meetings and such. So the release 16 finalization meeting is happening this week as we speak. So probably the 16 final spec will be out this Thursday and the meeting ends. And to your point, in 4G days, the standards were developed and then they would come to telecom networks and then industry would look at how can they use it and such. Instead of that, in 5G, actually, a lot of industrial folks, some of the names that you named, Bosch and others, they're actually actively involved in 3GPP itself in terms of giving their input. A lot of times, even debating across the aisle with the vendors and such on what they need, what is most important for them. A lot of times earlier, the telecom industry would assume what is important for industrial IoT related applications. But now, these are actually people giving live inputs on what they really need rather than people assuming what they need, right? So that's a very welcome change, and also gives me a lot of hope that time between standardization and actual commercial application of these things to the industry is much shorter than how it took for 4G, for example.
Absolutely. You nailed it. Yes, totally. And just to add to that, yeah, 3GPP and standards body, but even when we were in Qualcomm
Mhm.
5 years ago, when 5G research started, at
Yeah.
that time, building blocks of 5G was okay. We knew that the fifth generation for mobile technology, but when the research foundation was being laid, it was being laid on not only on enhanced mobile broadband, but this mission critical services like cellular vehicles, CV2X kind of thing, drone application and drone communications were thought about it. Massive Internet of Things were also thought about in terms of enhanced power saving modes, deeper coverage, narrow bandwidth, efficient signaling, and all of that were part of this research stuff that was done 5 years ago, and that's how it's being built. So it is, like you said, it's a welcome change across the board. It's just not a mobile technology, it is a technology that's broadly applicable and will be broadly changing, impacting a lot of areas.
Cool. So specifically on RB5, it is with 5G, but can it work with 4G network right now and can be upgraded to 5G when there are networks around, or how does that work?
That's a good clarifying question. And like I mentioned earlier, right, not every robot needs cellular to begin with.
Correct.
And leave alone 5G, right? Not
Yeah.
every robot needs cellular. So RB5 platform is true flexible platform like our heterogeneous compute platform. Even the RB5 platform is truly flexible. What I mean by that is you want just Wi-Fi and you don't need cellular, you can have that by itself. You need
Mhm.
4G. Yes, we have modem that's plugged and played, and we have the modem modules and few others which are already certified across multiple carriers and others, which is 4G, LTE, CBRS is also supported. And
Mhm.
then we have 5G, both the millimeter wave and sub-6 capable modem X55. So these options are choosable. Basically, you can pick what you want.
Yeah, specifically, these robots have very long life, unlike our smartphones. So you should be able to upgrade only part of it when needed rather than just changing the whole robot itself, right? When newer technologies come and such, like going from 4G to 5G, for example, especially with 5G,
Absolutely.
yeah, mission critical services which are not supported on the network right now, and when they come in, you should be able to upgrade your robot to that rather than just throwing it away like what we do with smartphones nowadays.
Absolutely. And we are serious about that kind of market, which is enterprise and industrial, where you need more extended life on the product as well. So this RB5 platform, which has at its heart the QRB5165 processor, that we have already extended the life of that processor for 10 years, which is mostly for the industrial and cases where you need that. More than that, we've also put the temperature rating on the silicon. We qualify this for industrial application. We have minus 30C to 105C junction, which is the industrial grade temperature that's also supported on this. So we have made sure that it's future proofed very well, not only the supply, but also the technology add-ons. Like if you want release 17, release 18, we could add on a modem later on to this platform that would be compatible with the forward compatible, backward compatible kind of things that future proofs yourselves.
Interesting. So now looking at the AI part of it, I know with a lot of edge intelligence and edge AI happening, how is this product able to do with the change in trends in terms of how much AI you do on the device, on the edge itself versus the cloud and such? How are you guys addressing or approaching this challenge of changing topology and such when it comes to AI?
Yeah, so AI is really interesting. Of course, there is, in terms of applications, there are real time applications. I would say there's a time for edge and there's a time for cloud.
Uh-huh.
And if you have to choose that, if this is drone and you need real time AI to be able to understand your obstacle, navigate around it, there's no time for you to go to cloud and come back, right?
Correct,
Or,
correct.
of course, by latency, you could potentially do that. But the round trip going to the cloud, coming back has additional costs to it. So you would want to do as much as possible efficiently on the edge. And when it's not efficient enough and you want further data aggregation, of course, there's cloud. We think edge AI is very, very, very important. And in this platform, I call it a beast, the QRB5165. It has 15 tops of compute capability for AI, which is unprecedented in this segment. I mean, we have competition part where it all ends at 3 tops. Now we are talking about 15 tops, 5 times more performance, more than anything. Of course, we are giving this lot of performance. We have a dedicated hardware called HTA, which has by itself 8 tops. Then on top of that, you have CPU, GPU as well. So 15 tops on the system is unprecedented AI you can get. But the kicker is we have the best in class inferences per watt. Of course, inferences per second you can get by putting a big blob of compute, even in server, for example. But on the edge, you need that kind of high instances, but you need it at very, very efficient thermal envelopes and power envelopes, right? So ours is best in class inferences per second, but at the same time, best in class inference per watt.
Really nice, exciting. So now IoT is the ecosystem of partners, developers, and the guys who do it. Unlike smartphone, where you have a few guys and get the stuff from you guys and do it. IoT is vastly different and diverse. The key to success there is very strong developer ecosystem and tools and the whole infrastructure to support them efficiently and effectively for them to make their applications work in the real world. So Qualcomm is famous for its smartphone ecosystem, but not many people know about its IoT ecosystem and the developer support and such. Give us a quick high-level overview on how the whole developer ecosystem support works for Qualcomm.
I'm glad you brought this up. And I missed this when we were talking about the challenges facing the robotics market. In addition to needing integrated processors which are power efficient, which all of this, that is great. I mean, which solves a lot of problem. But at the same time, you talked about developer ecosystem and all of that. But more than that, I think we have this 4-pillared strategy for ecosystem. We have scaling partners, which are manufacturing ecosystem like ODM, OEM. So if you want to make a robot and you don't know how to deal with Qualcomm chipset and Qualcomm boards and few other things, we have ODM and OEM partners that are part of our ecosystem that can help you with that. Then second thing is, okay, if you don't know camera technology and you don't know how to tune your camera, and we have technology partners that can help you with things around camera applications or camera tuning and few other things. So and then AI part also, if you want XYZ algorithm for machine learning model, we have partners in our ecosystem that have data to be able to meet the KPIs you need for face detection or any kind of AI algorithm for that part of it. And then, of course, we have the ecosystem around the robotics application. So we support things like ROS, AWS RainbowMaker, and on the OS side, we support Ubuntu and Debian and the Linux software part of things, which community and the ecosystem partners and the developer community is taking this and creating applications on it. So we have a very rich ecosystem that's around RB5. Already, I don't know if you saw the press release, but part of the follow-on we'll be announcing, we have 30 plus ecosystem partners are developing their applications on RB5 today.
Okay, very well. Yeah, I saw that. And then I think you mentioned a lot more are lined up that you're not ready to announce them yet, which I think is exciting. So one question that often comes when people come to Qualcomm and try to buy chips and such is about licensing. So how does licensing work for IoT vendors who want to buy the RB5 either from you directly or from a ODM that you mentioned and want to make a robot out of it?
So I think our business model, of course, is a little different for IoT. I mean, we have a great IP licensing business. We always make sure that that part of the business is not affected by what we do. In this case, of course, when there is no modem involved, we have click-through licensing models as well.
Mm-hmm.
But again, there's multiple choices. For example, if you don't want to deal with Qualcomm directly, we have partners who are our licensees, and you can get the hardware and software from them without even getting a license from Qualcomm, and you can develop on top of it, because we have partners who can redistribute and serve you in terms of services business if you need software support and all of that. So there is flexible model. I mean, it's not traditional licensing model like our mobile phone.
Okay, very well. Another thing that I was wondering was in terms of, I mean, you mentioned your tons of developers and partners are working on your IoT platforms. Typically, how is your robotics business distributed geo-wise and segments and industries wise?
I think, I mean, on a high level, if I have to take that question, I think we are geo-wise equally distributed across the world. Of course, like you mentioned, the nuances come in place where the segments, okay, consumer robot segments is a little bit higher in North America and China, cleaning robots, etc. But if you talk about factory and industrial robots, Europe and others have a little bit more, like Germany and others have a little bit more focus. But in general, if on a high level, we are playing across these segments, across the world. We have partners and customers. And in terms of segments, like I mentioned, consumer, enterprise, and industrial, these are the segments that we address, which is applicable across the world.
Okay, perfect. So now, mandatory question that I'm sure you are asked everywhere is COVID. How is COVID affecting your business right now? And then overall, I'd be more interested in long-term impacts of it. Mostly talking to many people, and I've seen as well, there is a lot of automation happening because I mean people can't get to work, can't get to their factories, can't get to their offices and such. So, what is your view on the effect of COVID in a short term and in long term on your business and on your robotics business, as well as robotics as an industry overall in the short and the long term?
Yes, I think unfortunate situation, very challenging situation. Of course, COVID across the world, across demographies. The COVID has affected different businesses differently. In terms of robotics, there is a significant push for automation, like you mentioned already, and there is things like contactless delivery, making sure warehouse fulfillment centers, and making sure you have quick deliveries and few other things. So we are seeing that the robotic segments that were just flat are going exponentially higher, especially around delivery. Example would be in Bay Area, there are a lot of OEMs who are doing delivery robots, and they have gotten accelerated approvals to start doing grocery deliveries autonomously. That's happening, and that's accelerated. In Florida, there was I don't know if you saw that news article where CVS had started doing drone deliveries of prescription medicine to old age homes to avoid any kind of contact. So that is happening as well.
Uh-huh.
And then in warehouses, you have workers turnarounds where you want to maintain distance between on an assembly line. There is an adoption of cobots that is also happening. So I think there's a lot of positive impact. And I think as we come out of COVID also, I would see this becoming mainstream, because it was going to be that way, but COVID has accelerated some of this.
I see. You mentioned a cobot. Is it what, a companion robot or?
Yes. Cobot stands for collaborative robots.
Okay, perfect. So I think that's all the questions I had. Did I miss anything covering the robotics to high level? Any closing comments you might have?
I think we covered it all. I think the future is tremendous with the unisons of AI, 5G, and things that are going to happen for robotics and for this stuff like drone deliveries, unmanned aerial vehicles, and all. I think we are all excited. I mean, phenomenal time we live in, of course, and the technology is enabling all of that. So I think we covered a lot of stuff. Of course, we can go into details of 5G and few other things at later point. But yeah, this was great chatting with you.
Excellent. Same here. It was very nice. Thank you very much for coming on to Tantra's Mantra. And we learned a lot of things. Very exciting times ahead for robotics, it seems like. And all the best for your RB5 platform. I think, I looked at some of the spec. It indeed looks like a beast. And I'm sure you're working with a lot of partners and such to really bring it to life in many applications and services and such.
Oh, thank you. Thank you for having me.
Sure. All right, folks. That's the end of the podcast for today. Hope it was informative and useful. And, if you think it was useful and informative, please do subscribe to our podcast if you have not already done so. I'll be back soon with another episode, putting light on another interesting tech subject. Bye bye for now.